Welcome to Physics Lesson 5B. Please open your notebooks to page 47. Now, we're talking about work today. And when I say work, I mean by energy, we're using a measure of an object's ability to do work. And more energy means we can do more work. And by work, we mean the transfer of that energy from one object to another. So, for example, say a handsome and ripped weightlifter is lifting a gigantic barbell above their head. That's work getting done. Okay. So, of course, we have another fancy formula for ourselves. And what we're looking at here is W equals F delta D. It's a pretty simple formula and one to add to our list. And we can do a lot with it, especially when we combine it with our previous knowledge. So the W is equal to work, and we measure that in a unit called joules. And then F equals force. Now we learned about that recently, that's newtons. And then delta D, our old friend, is distance in meters. So since work is a form of energy transfer, it gets the following units. Work equals units of joules, which is just our old equation of the Newton times meters. So it's just nm. And nm, when you put that together, we call it joules. So it's all information that we already have and we already know, and we're just multiplying that by meters now, is really what's going on here. So let's just once you're done copying this down, let's take a little time to do an example. So here we go. Kaylee pushes Chelsea on her rollerblades for a distance of 15 meters. If Kaylee exerts a force of 225 newtons on Chelsea, how much work has Kaylee done? Well, Grasp, our old friend, I know you can help us here. All right, so let's see. Let's start with the given. Now, what is this giving us? All right, so I can see from this, we're talking about a change in distance, or delta D, of 15 meters, and the force that we're talking about is 225 meters. Okay, so what's required? How much work has Kaylee done? Okay, easy peasy. We're talking about work. So W is our question mark. So now let's analyze it. Let's take this new equation we have. Work equals F delta D. And hey, what do you know? We don't even need to mess around with it. We just need to plug in some numbers. So let's do that. We're going to solve it right here. Boom. So easy peasy. The force, that F is 225 newtons times 15 meters. Okay, we can math that pretty easy. We're talking about 3,375 Newton meters. Or what else can we call that? We could call that joules. But wait, let's back up here. If we look at the numbers that we have here, we're talking about 15 meters, so that's 2 significant digits, and we're talking about 225 newtons, so that's 3 significant digits. So I'm going to have to turn this into scientific notation so that my least well measured item of 2 significant digits is represented here, because my product has to be only 2 significant digits. Okay, so let's do that up. And to do that, we're going to, again, of course, move that decimal point, so there's only one number in front of it, so we'll have 3.4, and that way there's 2 significant digits. And then I'm going to move my comma, my decimal point 1, 2, 3 to the left, so I know it's 10 to the 3. And then we're going to put joules instead of Newton meters, because that's just what we call it, because we're scientists. Now take a second here, copy this down, make sure it's in your notes so you got it. Pause it if you need to, that's okay. Just restart once you're ready to roll. Okay. So we also need to paraphrase this. So how would we do that? Just so someone knows what we're talking about, and so I know that you know what you're talking about. So I'm just going to say if Kaylee pushes Chelsea with a force of 225 newtons over a distance of 15 meters, she will have performed 3.4 times 10 to the 3 joules of work. All right, now speaking of work, let's get to work and do one more. Okay, if Melvin and Bryce push a cart with a mass of 63 kgs and speed up from 0.5 meters per second to 6.0 meters per second in 5.55 seconds over a distance of 8.35 meters, how much work have they done? All right now is where you pause this and you get to work. Now, hint, start with your old friend grasp. If you don't know what to do, start with that. Start with what is this telling us? What is given? So go ahead and pause right now. All right, you did it. Well, let's go over it together and let's see what we come up with. So let's do it together right here. So we have our acronym GRASP. So given, I can look up here and I have 63 kgs is my mass. Then it says this Melvin and Bryce make that cart speed up from 0.50 meters. So that's our initial velocity. Is 0.50 meters per second. And then to 6.0 meters per second. So our final velocity, that second velocity, is 6.0 meters per second. Okay, and then delta t, we're told right up here that we're looking at 5.55 seconds. And we're told that the change in distance is 8.35 meters. Okay, so then it asks us how much work have they done? Okay, so W is our question mark. That's our required. Perfect. Okay, so now we're going to have to analyze this. So I know that work equals F delta D because that's my new equation. I have a few master equations in my tool belt now, and this is the one that I have. Okay, so I'm plugging it in. So now let's see. We don't have force written down as part of our given information, but I know from previous lesson that force equals ma. I know that's another equation in my tool belt because I probably have a little cheat sheet that has them all written down there. And that way I can just plug it in like a detective, and it's kind of fun because I just got to make everything fit. So the way that I can do it, just to kind of make it easy for myself, is I can actually just mess around with the equations right now. I don't even need to plug the numbers in quite yet. This is part of my analysis. So I know that I have a mass and I have acceleration because I also know how to figure out acceleration from a previous formula. So if I multiply all these together, I'm going to have mass times, okay, what's acceleration? Right, it's delta V over delta T. And I know that delta V, or the change in velocity, is going to be that final velocity minus that initial velocity. And that'll tell me the change in velocity. And I'm going to divide that by the change in time to get my acceleration. And then just because it goes back to the formula here, I know that I have to multiply that by delta D. Okay, so that is a big equation. It looks super fancy because it is super fancy. But we're ready to move on because I have all of these. Now I just need to plug it in. Easy peasy. So I'm going to solve it. I'm going to write down a whole bunch of fancy numbers here. 63 kgs is my mass. Then I have 6.0 meters per second minus 0.5 meters per second. Again, that's my final velocity minus my initial velocity times 8.35 meters divided by 5.55 seconds. And bam, just like that, after I cross out all my little units here, I'm going to be left with N and M as my units, and I'm going to have 521.3 Newton meters. So when I think back, I'm like, oh yeah, Newton meter, that's what a joule is. And then I'm going to look at my significant digits. So my least accurate number here, My number with the least significant digits is 2. I have 2 significant digits in 0.50 and 6.0. So I know my answer has to be in 2 significant digits. So again, I'm going to change my 521.3. I'm going to move that decimal point so there's only one number in front of it, which is a 5. So I'll have 5.2. And to get that, I had to move my decimal point 2 spots. So I'm going to say 5.2 times 10 to the power of 2 joules. Wow, that is a mouthful. Okay, I'm going to invite you again right now. Just take a little pause. Make sure you have this all written down. If there were some inaccuracies in what you did, that's great. We're learning together. And if we find where we're not quite doing it accurately, we can do it better next time. So that's good. Pat yourself on the back. You made it through this. Okay. Go ahead and pause it now. Get this copied down. And finally, do this now, please. We're going to do the practice assignment on pages 48 and 49 of our booklet. So that's lesson B, pages 48, 49. And then move on to lesson 5C, where we're just going to look at how this looks on graphs. See you on the other side, and good luck.